Now we'll talk about arrays. Imagine you need to store the scores of all players in a game. You could create separate variables for each score, but that would be inefficient. This is where arrays come in. They allow us to store multiple values of the same type in a single variable. In C#, arrays are type-safe, meaning all elements must be of the same data type. There are two types of arrays. First is single-dimensional array and second is multi-dimensional array. Let's first talk about single-dimensional array. A single-dimensional array is a collection of elements stored in a single line, or one dimension, where each element is accessible by an index. Think of it as a row of containers, each labeled by a number starting from 0 up to the size of the array -1. In C#, single-dimensional arrays are a fundamental data structure that allows you to store multiple values of the same data type in a single variable. To create an array, we need to set its data type followed by brackets, then array name, and then initialize it with curly braces and put the data inside it. Like here, I created an integer type array, named numbers, and initialized with integer values. To access the item of the array, we can access it directly by the index of that item. Like here, I'm fetching the first item from the array using 0 index. However, to fetch all the elements of an array, we need to use for loop or for each loop. Like here, I used both for loop and for each loop to iterate over this array. In for loop, I have set length of it equal to length of numbers array. Inside it, I printed the number array by providing it the current index of iteration. In for each loop, I've set it to iterate over the numbers array. And inside it, I simply printed the element of current iteration. Now run the program. Both loops ran 5 times and printed same values. Important note, in C#, arrays have a fixed size once created. You can't add or remove elements. You'd need to create a new array if you want a different size. Now, let's talk about multidimensional arrays. Multidimensional arrays are collections of elements arranged in more than one dimension, like rows and columns. The most common is a two-dimensional array, often visualized as a grid or table, but you can create arrays with more dimensions if needed, like three-dimensional arrays represent data in a 3D space. They're useful for representing data in structured formats where you need multiple levels of access. In C#, multidimensional arrays help represent complex data structures, such as a chessboard or a spreadsheet, where data is organized by rows and columns. There are two ways to create arrays. First one is this. Here I put comma inside the brackets to declare integer type multidimensional array. Then I initialized it with new integer array with 3 rows and 3 columns. Later, I put curly brackets to add data. Inside it, I put curly brackets again to put data row by row. Each of these curly brackets here represents a row, and each value inside the row represents a column. As we declare this array to be 3 by 3, we must create 3 rows and 3 columns. Second method is to initializing it using shorthand like we did while creating single-dimension array. Like here, I created the new matrix array without specifying the number of rows and columns. I simply put the values and C# will automatically set the number of rows and columns. However, number of columns must be same in all rows. We can directly access an element from the multidimensional array using the index of that element. Like here, I want to access the first element of this array, so I used 0 row index and 0 column index to get the first element. And to get last element of the second row, I used 1 row index and 2 column address. Now run the program. Here, first element of the array and last element of the second row is printed. To access multidimension array, we use for each loop as before. It will automatically get each element of the array from each dimension. Now run the program. Here all elements of the multidimensional array are printed. If we want to use for loops, then we have to create nested for loops. Right now, I created two-dimensional array, so I need 2 for loops. Like here, I created 2 nested for loops. Important note, we need 1 for loop for each dimension of the array. For example, if you create 3-dimensional array, you need 3 nested for loops, 4 for 4 dimensions, and so on. In first loop, I have set the length using getLength method of array. It returns the length of specific dimension. So, I provided it 0 to get length of first dimension, which are rows. Inside inner for loop, I again used getLength method, but now I provided it 1 to get the length of second dimension, which are columns. Inside it, I printed the element from matrix by providing the index using I and j variables. Now run the program. Here, both for each loop and nested for loops printed the same values. However, nested for loop gives you more control to execute some code over each iteration for outer loop and inner loop separately. Now, let's talk about array method. C# provides several built-in methods for arrays, making it easier to manipulate and manage array data. Let's talk about 3 most basic methods. First comes the sort method. Sort method is used to sort the arrays. Like here, I sorting the numbers array using array.sort method. Now run the program. Number array is sorted. Next comes the reverse method. Reverse method is used to reverse the order of array's elements. Like here, I reversing the numbers array using array.reverse method. Now run the program. Number array is reversed. Next come the index of method. Array.index of method is used to get the specific element of an array. Like here, I created the variable and assigned the index of method. Index of method takes 2 parameters, first array and second index, to fetch. After fetching, we can use this variable anywhere we want without affecting the original array. Now run the program. Element at the index of 3 is displaying here. That's all for this section.